Hi, I'm Adam. Welcome back to Godot Game Lab. In this episode, we'll tackle combining units into higher tier ones. So when I buy a unit from the shop, you'll see that we have this new icon here which indicates which tier that unit currently has. So when we buy a unit, it will always be tier 1. If we buy a couple units, you see nothing happens. But if I start buying more units in a quick succession, like this, you'll see that the combinations start to happen one after the other. And if I were to buy another couple Robins and Björns, these combinations keep happening. And what's interesting is if I buy another Robin, these will combine into a tier 2, and the tier 2s will combine into a tier 3, like so. Without further ado, let's see how we can do this. I know this episode is about the UnitCombiner node, but first we have to do some prep work. First of all, we have to introduce tiers to the units and animations, so when we mesh together 3 of those units, we see some visual feedback. Let's take our unit scene as a starting point. The first thing we want to do is to change our unit stats resource. We'll introduce a new property called tier, which will be an integer. Then we'll create a new scene called TierIcon, which relies on having access to a unit stats resource. This tier icon will have one function only, namely changing the tier icon according to the number we'll have in the unit stats resource. Units can have 3 different tiers, each of those with their own icons. You can see that both the unit and the TierIcon scenes use that unit stats resource to do their jobs. However, there is one more connection, namely that this tier icon will be instantiated under the unit scene, because each of those unit instances have their own tier icons indicating their current state. The animation component is much more simple compared to this. It will be just a component, a plain old node like the other ones, which is solely responsible for, well, animations, right? So we'll have different constants and methods for all the unit animations that are inside the game. We could have done this inside the unit scene or the unit script itself, but in order to break it down into smaller manageable pieces, why not make it a component, right? Again, we have a relationship between the two. So the UnitAnimations component will be instantiated by all units in the game. So with all the prep work out of the way, we can move to the UnitCombiner next, right? Well, yes, but before we move on to the architecture, let's look at some real-life or in-game examples of how the UnitCombiner works, because looks can be deceiving. This UnitCombiner sounds like a really simple, straightforward thing to implement, right? If we have 3 or more matches, we just combine them. Well, yes, but it's much more trickier than it seems at first. Let's take a look at this example. So when we have the shop, which you can see on the top, and we have this unit bench, what happens when we buy Björn? We hover the mouse over our Björn unit in the shop, click on it, and what happens is a tier 1 Björn gets added to the bench and they immediately combine into a higher tier unit. What's the problem with this approach? If I roll back the animation, see for yourself again. The whole thing happens just way too fast, right? As a player, you don't have the time to comprehend what's going on because as soon as I click on it, the unit spawns and they immediately combine into a higher tier unit. And that doesn't really do it for us from a UX perspective because it's just too fast and you can't really understand what's going on. So that's a challenge. How can we solve this? Let's take a look at the same example again, but this time we'll add a buffer time between buying the unit and combining all the units together. So again, if I hover over to Björn in the shop and click on him, a timer starts and I only combine those 3 units together when the timer expires. One more time. Even though this is slower technically, it's much better from a player perspective because you have the time to comprehend that, okay, I got a new unit, 3 of those are on the board, so they should be combined together. So far so good, right? This solves one of our problems. Well, yes, but the problem is that I can click on these units as fast as I want, right? So what happens if I click on Björn and before those can combine, I click on a Robin unit as well? If I only have that 1 second timer, the problem is that by the time I move my mouse from Björn to Robin and click on him, the combination can happen practically as fast as in the first example, because by the time I move my mouse over to Robin, that extra buffer timer most certainly almost expires, right? And whenever it expires, I start combining the units. So how do we solve this? Well, it's pretty easy actually. So when we click on Björn and buy him, the timer starts. And when we move on to Robin and click on him as well, if the timer didn't expire yet, we restart it again. So click on Björn, move on to Robin, and you'll see this smooth process of restarting the whole thing. Let me play it again, but slower. So we click on Björn, the timer starts, we move on to Robin, the timer restarts, then 3 Björns combine, and finally, after they combine, 3 Robins combine as well. This gives us a very streamlined process of combining the units together, and I think it's a good compromise between speed and UX from the player's perspective. One final thing we need to think about is something that can complicate the whole code even further, and that's chaining together combinations. So if I have a bench like this with 2 tier 2 Björns and 2 tier 1 Björns, what happens if I buy another tier 1 Björn, right? So what should happen is that the timer expires, the 3 tier 1 Björns combine into a tier 2, then I end up with 3 tier 2 Björns, and they have to combine into a tier 3 unit as well. And this should happen automatically. This is not an issue per se, I just wanted to highlight what challenges come with designing a UnitCombiner system or component like this. So with all of these visual explanations out of the way, how do we do the architecture for this component? Well, let's see. So we have our UnitCombiner component, and I've used some color coding to sort of indicate what we're working with. So we have a buffer timer, a queued updates, and a tween property. So the white ones are properties. The buffer timer will be a timer, sort of the yellow circle you saw. The queued update will be the number of updates we should currently do. And that's according to how many units we bought in quick succession, basically. We'll also have a dedicated tween property, so we can know if there's an animation currently playing or not. We have a method called queueUpdate, which will be quote unquote a public method. So this will be the one we expose to other systems in the game. So queueUpdate means that when we buy a unit, the UnitCombiner should check if we need to update anything or not. This essentially just adds 1 to the queued updates number. Then we have a bunch of private methods with yellow, and we have some callback methods with orange. So instead of explaining all these methods one by one, let's take a look at the flowchart and the logic of the whole thing. So when we buy a unit, it will queue an update. This basically means that we add 1 to the queued updates and start the buffer timer. After the timer runs out, we call this orange method called onBufferTimeout. And what we do is we call this update unit combinations method. But when the timer times out, we only start updating the unit combinations if we are currently not animating any other combinations. So we check if the tween is currently running or not. Another thing is that since this triggers when we buy a unit, we always start updating unit combinations from tier 1. From the bottom, right? Because we can only buy tier 1 units. So what does it mean to update unit combinations? Well, we want to basically group the units based on their tier and their unit names or their unit types, and sort of grab all the triplets that are available, right? Because these triplets should be combined into a higher tier unit. And then we should combine those and tween the animation for each triplet one after another. Mind you that this last step is only needed when we actually do have valid triplets. So basically when we don't have triplets, we have to do nothing, right? And this is the flowchart for one specific update, but this is an iterative process, so we need to repeat this. And there are 2 reasons or 2 cases where we can repeat this whole process. Either because we bought another unit, meaning that we have a next update queued, then we start the whole thing over from tier 1, but we can restart the whole process from the buffer timer for another reason, which is when we finished a tier 1 update and we want to chain it up as we talked about it. So after we finish the tier 1 update, if we don't have new tier 1 updates queued, we can update the tier 2 units as well. Because you saw that it might happen that we bought a 9th unit, and in this case, 3 tier 2s should combine into a tier 3. So we have to handle these two very different cases. Again, either because we queued another update on tier 1 with buying a unit, or when we don't have any other updates queued, we can move up a tier and run the whole process for tier 2 units. Hopefully that makes sense and sort of provides an introduction to the problem we want to solve in this episode. So let's jump into it. So with the project open, we can do the changes that we proposed in the architecture section. The first of which is to update our unit's stats script. So let's go to the script tab, press Ctrl-Alt-O and search for unit_stats.gd. And we said that we need to update this, but I forgot that we already added the tier, so we don't really have to do anything here. Just make sure you check that you have this export variable for the tiers set. The setter function is pretty simple. What it does is it changes the value and emits the changed signal to make sure that anything can connect to that signal and update accordingly. Just like we needed with the tier icon. Okay, so we don't really have to do anything here. Let's go back to 2D view and create that scene for the tier icon. So click on the plus icon here to create a new scene. Click on other node, and our root node will be a texture rect. So let's search for texture rect, double click on it and rename it to something like tier icon. And let's not forget to save it. So press Ctrl S to save this. Inside our scenes folder, we can create a new folder by clicking on this icon. Tier_icon is perfectly fine for the name and the folder name as well. Click on save. And you can always check that we saved the scene. And for the texture, we can click on the arrow and press quick load and search for level1.png, which will be used for the tier icon. And you can immediately see how it looks like. And if we click on the texture, you'll see that it's a 10 by 10 image. So actually the keep size property is not too bad here. But to make sure that it doesn't stretch in any way, we can change it from scale to keep aspect centered. And under layout and transform, we can reset the size because it's 40 by 40, which is way too big, to 10 by 10. And you can see that inside a 32 by 32 tile, it looks much smaller now. And just to make sure that it never gets smaller than this, we can set the custom minimum size to 10 by 10 as well. And that's all we really need from the inspector side. We can click on attach script to create a new script for this. TierIcon.gd is fine, but we don't really need to use any templates, so we can uncheck the template button and click on create. Okay, so this will be a pretty straightforward script to do. The first thing we do is we'll add a custom class name called TierIcon. Then for the icons for the different tiers will be stored inside a constant, which will be a dictionary. The key will be the tier itself, which is an integer number, and the value will be a resource, the corresponding texture that is loaded with preload. So for the key 1, we have level1.png, for 2, level 2, and for 3, level 3. And in order for this to work, we already established that this scene uses a UnitStats resource. So we'll have an export variable called stats, which will be a UnitStats resource with its own setter function. And the setter function will look like this. First of all, if the previous stats we have is equal to the value we want to set it to, then we can return from the function immediately because we don't have to do anything. Then we can set the value to the new value. And if that new value is null, we can return from this function immediately. This is just to make sure that the game doesn't crash when we test this scene with no unit stats assigned. Because if we don't have a unit stats, we cannot get access to the tier, so we cannot really use the dictionary to grab the corresponding texture. And this check makes sure that we don't even want to access the dictionary if we set the stats to null, to an empty value. Now, if it's not null and it's not the one it was before, we might want to check for the node's ready signal if the export variable was set previously in order to test the whole thing. And when we are sure that the stats is a new value, it's not null, and the node is ready in the scene tree, we can connect to the changed signal of that resource with our own callback method called onStatsChanged. And just to make sure that the icon immediately updates, we can actually call that method as well. So what do we want to do when the stats change? Well, it's pretty simple. We set the texture property to the new one by grabbing the correct one from our dictionary, our constant here. And for the key, we use the tier that the unit currently has. And that's it. You might think that this setter function is overly complicated, but if you break it down step by step, it's not that complicated, I think. So we can save this script with Ctrl S. And if we go back to 2D view, we can test this in isolation. That's why we did that quote-unquote complicated setter function. You see if we have no stats assigned and run the scene with F6 or by clicking on this button, we have no error messages or crashes. If we close the game and assign a unit stats resource, let's click on this arrow and quick load one. Let's use Bjorn test we have, because that's a tier 3 unit, so we can test if the icon actually changes or not. And if we run the scene again, you'll see that we have that tier 3 or level 3 icon instead of the one we use by default. So that pretty much works, and we can reset this stats resource to empty, save the scene with Ctrl S, and our TierIcon Scene is done. And the next logical step would be to hook this up inside the unit, right? So press Ctrl-Shift-O and search for unit.tscn. We can close the output window for now. Select the root node, the unit node, and click on this button or press Ctrl-Shift-A to instantiate a child scene. And search for TierIcon.tscn. To make sure that our hierarchy is organized, we can drag this up to the other UI nodes. Scroll in a bit, go into move mode by pressing W, but if you try to move the icon now, you'll see that with grid snapping enabled, it looks a bit weird, and I can't really position it however I want it to, so we can use this button or press Shift G to disable grid snapping. And if I click, press and hold Shift while dragging, I can drag this to whatever position I like. And I kind of like how it looks like. So we can go back to selection mode by pressing Q on the keyboard, and we can toggle back grid snapping with Shift G. And we do have our tier icon, but we actually have to hook this up inside the unit script. So let's click on the script for the unit. And if we scroll all the way up, we have a bunch of already variables. And again, just to keep things organized, I want to have an already variable reference between the menu bar and drag and drop component. So add a new line here, click and drag the tier icon from the scene tree. Press and hold Ctrl when you release it. And the tier icon already variable reference will be added to our script. And the one thing we want to change is if we go to our set stats method when we set the unit stats resource, after changing the skin's position, we can just add TierIcon.stats should equal to stats, the new resource we set. And with this change, 2 lines of code, we should have our tier icons working with the units as well. Let's save the script with Ctrl S and let's see if we can test this. Let's go back to 2D view. And for the unit, we have Bjorn.tres. So if we run the scene with F6 or by pressing that button, we see that the unit's positioning makes it kind of awkward to test, but let's not forget that we have our drag and drop component, so we can just drag him around, and we see that tier 1 icon here. But if we click on Bjorn.tres and set the tier to 2, save the whole thing with Ctrl S and run the game again by pressing F6. If we drag him around, you'll see that our tier icon works because now we have that silver level 2 icon. Awesome, so let's not forget to set Bjorn back to a tier 1 unit by default. Save it again with Ctrl S and we're good to go with the tier icon. The last bit of preparation we need before actually making our UnitCombiner component is creating the UnitAnimations component. So inside our file system doc, let's expand the components folder, right click on it, create a new script. Let's call it unit_animations and turn off the default node template, click on create, and double click to open it up inside the script editor. Okay, so what do we need from this component? This will be responsible for all the animations the units will have inside this game. So first of all, we'll provide a custom class name called UnitAnimations. Then we'll have a bunch of constants related to the combine animation. So we'll have the length defined as a constant, which will be 0.6 seconds. We'll have a scale, so we scale down the 2 units that will sort of animate towards the first unit of the triplet. So we'll scale down the unit to 70%. Basically. And then we also have an alpha value which we want to tween towards to make it look like the units are kind of disappearing. So we'll say that by the end of the animation in 0.6 seconds we'll animate this unit to 70% of its scale and 50% transparent. So for this component to work, we need an export variable to the unit itself to make sure that we can change its position, its modulate, and all those things. And for now we'll only have one method called playCombineAnimation, and we we only need one piece of data, which is the target position we want to arrive at by the end of the animation. Then we'll create a tween, set its easing and its transition properties. I just picked two that I think looks nice for this purpose. If you don't know, there's a really good cheat sheet that sort of visualizes how these different properties work. I'll leave a link to it inside the documentation. Then before we start animating, just to make sure that everything looks nicer, we hide the health bar, the mana bar and the tier icon of the unit. It makes the animation look much smoother in my opinion that we hide the UI connected to those units. Then the real tweening happens. So first of all, we tween the global position property of the unit and we want to arrive at the target position after the 0.6 seconds we have defined as a constant. Then with the parallel method, we can sort of chain these three tweens together. So basically simultaneously, we want to animate the scale to the target scale for the same length and the modulate properties alpha value the same way. And with tween.tween callback, we can say that when this animation finishes playing, we can delete both of those units with Q3 because when we combine three units together, only one higher tier unit should remain. Right? And that's pretty much all we need from the UnitAnimations component. So let's save this script with Control S, and we need to hook this up before testing. So let's go back to 2D view. And I need to take some time to thank each of you again because I always keep learning from you too. So I've done adding these components in a pretty tedious way by adding a single node and dragging and dropping the script over. And as many of you pointed out in the comments, there's a much easier way to do this now in the engine. So if we select our unit node, the root node, and press Ctrl A or click on the plus sign to add a new node, we can actually search for the components we created. So if I search for UnitAnimations.gd, because we use the class name, I can add this as a node. So if I press enter now and click on create, it will be added with the script attached. So it's actually much easier than the way I did it before. So thanks again for pointing this out. But after we added the component, either way, we have to set the export variable. So the unit will be assigned to that component. So that's all it takes to hook this up. So we can save this with Control S, and we need a way to test this, right? Okay, so we can't really test this in isolation because we need at least 3 units, right? So what we can do is we can go back to the arena scene because we do have 3 units lying around here. And for testing purposes, it's completely fine to use the arena, I think. So let's click on the script next to the arena. And we can add some testing code like this. So what we do is inside the input callback, if we press the enter button, the UI accept action, we use getTree.getNodes in group because all the units are put inside the units group to grab them as an array. And we'll say that the second and the third unit from that array should play its combined animation towards the first unit, right? Pretty straightforward stuff. So if we save this with Control S and play the game by clicking on that button or pressing F5, we should be able to test this. So let's move them around a bit. And if I press enter, we do have an error message because I forgot to do one thing, right? And that is changing the unit script after adding that UnitAnimations component. Well, because if we go to the units script, so let's press Ctrl-Alt-O and search for unit.gd. If we scroll all the way up, we have all these already variable references, but we haven't added one yet to our animations. So we do have the node added to the scene tree, but we have no way to access it through the unit. That's why we have this error message, because I forgot to do this. So let's stop the game for now, go back to the unit scene. And since we do have our UnitAnimations component here, we can just drag and drop it while pressing and holding Control here, and we do have that reference now. But I actually don't really like how this is called UnitAnimations. Why? Well, because if we take a look at our testing code here, units.UnitAnimations seems a bit redundant to me. Since it's always attached to a unit as a component, it will be always connected to a unit, right? So I think after dragging and dropping it over, it's fine as a component name, because components are dumped to the same folder, but as a variable name, I would suggest changing this to just animations, because then we have an access route like units or unit.animations, which is much better than unit.unitanimations in my opinion. So by adding this line of code and saving it with Control S, now we do have access to our animations component. So if we go back to our testing code, it now should work, but let's not forget to change this to just animations because we renamed it, right? So this should be units1.animations.play combine animation like this. Okay, that should fix it. So now if we run the game with F5, move the units around again, and press enter, now the animation plays. But have you noticed anything weird? Let's run it again. Now slow it down this time in editing. So if I press enter, you see how the units go towards the global position of the unit, and that global position is not the center of the unit per se. Because if we go back to 2D view, you'll see that the unit's coordinates will be at this position, right? So if we take a look at the grid, we sort of have to imagine that we need to move towards the center point of this whole thing. So we need to apply an offset. And that offset should be a positive one because we want it to move towards the right and downwards. And we can move on both of those axes if we use two positive values and add it to the position. So let's go back to that testing code we have. And instead of just using the global position, we can apply a plus quarter cell size offset, which will be 8 pixels on both axes. And with this addition, if we save it and run the game again, let's move them further apart so we see how it looks like. And now they animate towards the center, the sort of the belt of Björn, right? Okay, so now we see that the UnitAnimations component works as intended. We can always rely on that component to just combine units. For now, I'll leave this testing code in, but at the end of the episode, we'll delete any testing related code, I promise. If you like my content, please consider checking out my Ko-fi page where you can donate one time or become a member and get early access to all my content and videos. Now we can move on to the hardest part of the video, actually creating that UnitCombiner component. So let's go back to 2D view, right click on our components folder, create a new script, and let's call it unit_combiner in snake case. Click on create and double click to open it up in the script editor. Okay, so how can we make sense of this whole thing? Let's try to remember the edge cases and the flowchart we presented in the architecture overview. So first of all, we'll create a custom class name called UnitCombiner. Then we had those 3 properties we have to provide. One of those will be an export variable to a timer node, which is called buffer timer. Then we'll have 2 simple properties, one for the currently running tween and the number for the currently queued updates we have for tier 1 combinations. Then inside the ready callback, we have to connect to the timer node's timeout signal with our callback method. Meaning what we need to do when that yellow circle expires, right? That added extra time so the update doesn't happen immediately. Then we have probably one of the easiest methods here, queueUnitCombinationUpdate, which is the public method we expose to the arena and to other systems in the game. And queuing an update is really simple. It's just starting the buffer timer. And this has that added benefit we saw in the architecture part. If the timer is currently running, let's say it takes 1 second to time out, and if we are at, 0.5 seconds, and this method gets called again, the start method will restart it by default. So that's exactly the behavior we want because remember, we can buy units in quick succession and then we want to sort of delay the whole thing further. But now moving on to the harder private methods. Let's start with update unit combinations, which is the highest level method. That's basically saying, okay, give me all the updates for the tier we have as a parameter. How does that look like? First, we need to have 2 variables. One will be called groups, and we'll call another method we are yet to implement, which groups units inside a specific tier by their names. What do we mean by that? If I have 4 Björns and 2 Robins on my bench, and all of those units are tier 1, if I call that method for tier 1, it will return a dictionary where the keys will be Björn and Robin, and the value will be an array of those unit instances. And in the case of triplets, we'll call another method with this new groups variable we just grabbed called getTriplets4Groups, and this will return an array of arrays, basically all the triplets which are available inside those groups. So again, if we have 4 Björns and 2 Robins, it will be only 1 triplet, 3 Björns, right? But we can have multiple triplets if we buy units in a real quick succession. So if we had, 10 tier 1 Björns on the bench, it would return 3 arrays of 3 units, right? So 3 triplets. And if we do have the triplets, we can actually make the combinations. But it can happen that this triplets array is empty, meaning we have no groups of 3 units for the same tier. And in this case, we can return from the function immediately. But before that, we have to call this onUnitCombine callback method, which will be another one we'll implement at the bottom. And this essentially makes sure that we register this call for the update to be a successful one, meaning that it's ended, right? Why do we need this? It's because we queue updates, right? So if I buy 5 units real fast, 5 updates will be queued. And it can happen that out of those 5 updates, there's only one where the actual combination will happen. And all of these other ones need to finish successfully too. In this case, it means that we know that we can't combine anything, but we should decrease the number of queued updates by 1 because we successfully did update. It's just the case that we actually didn't have to do anything. But what happens if we do have something to combine? Then we can create a tween to make sure that there's a delay between the combinations so they don't happen simultaneously. Then we can loop through all the combinations inside our triplets array, and each combination will be an array as well. More specifically, an array of 3 unit instances. So what we do is we call our combine units method, which we are yet to implement, and bind the 3 unit instances from the triplet as parameters. This combine unit method will take care of playing the animation, increasing the tier of the unit and all that stuff. And once we called that method, we make sure that we add a tween interval, because if we have multiple triplets, we want to wait for the previous animation to finish before combining the next one. So that's why we have this tween interval here. So if we have, I don't know, 2 or 4 triplets, it won't combine simultaneously. And after the tween is finished, meaning that all the animations were played, we do the same thing we did here when the triplets were empty. We call that onUnitCombine method, essentially signaling that, okay, this update ran successfully. And we use this connect one shot, which is a neat little trick you can do with connecting signals to each other, which ensures that this connection between the tween's finished signal and our callback method will only fire once. And then the connection will be automatically removed between those two. This is just a safety measure because we only want to call this once when the tween finished playing. Okay, so that's all we really need from updating the unit combinations. It's a really high level thing, but we need to sort of put together all the puzzle pieces that we are still missing with these red lines of code. So what's next? How do we combine 3 units together? This is the method that we call from the tween here for all the triplets we have. So the parameter will be 3 unit instances. That's what you can see here. And the first thing we do is we grab the first unit stats resource and set its tier to a higher one than it was before. Then, even before playing the animations, we remove unit 2 and 3 from the units group inside the game. This is just to make sure that from the moment we register that these should be combined, they won't be treated as units you can interact with inside the game. And after we did that, we can play the combine animation from the UnitAnimations component on unit 2 and 3 respectively. Mind you that we use unit 1's global position as a target where we want to animate towards, and we also apply that quarter cell size offset from the arena, like we saw in the testing process, that we need that so it doesn't animate weirdly towards the top left corner of the unit. And combining the units takes nothing else, right? Before moving on, you might have the question like, hey, Adam, okay, but what about the whole unit grid thing? We said that when units are removed from the unit grid, they should be deleted immediately. And yes, that's the case, but it's not really a problem here because if you remember that play combine animation method ends with deleting the unit with queue-free. And when we got rid of that weird little read object bug, we had a dedicated episode. Inside the unit grid, we connected to the units 3 exited signals, right? And when they are queued for deletion, when they are being deleted from the scene tree, the unit grid will take care of automatically removing them. So we don't have to worry about this anymore here, which is awesome because in this context, we don't really want to manage anything related to the grid position of the units. We just want to handle the combination related stuff, right? This is why I think it was a great solution and I thought it was worth mentioning here. Okay, so now we have our combine units method ready to go. Now we have those 2 heavy lifting methods we call at the beginning of this update unit combinations method. First, when we group the units inside the tier by their names, and then when we provide the triplets for those groups. So to make it easier to know what's going on here, I added some comments, which I rarely do in these courses, but here I thought it makes a lot of sense. So as you can read, we'll return a dictionary of units grouped by name and tier, where the keys are unit names and the values are arrays of all those unit instances. So we have one parameter, which is the tier we want to group, and we return a dictionary. So the first thing we want to do is grab all the units that are available, right? So we'll use getTree.getNodesInGroup. And then we have to filter through those units, first of all, by their tiers. Because if I want to update tier 1 units, I'm only interested in all the tier 1 instances. So we'll use array.filter for this, pass in an anonymous function, and we only retain units where the unit stats tier property matches the tier we have as a parameter we want to filter for. Okay, so now we have an array of units which are matching the tier we want to check. And now we create a dictionary for the final unit groups we'll have. And what we do is we iterate through that array of filtered units, and for each unit, there are two cases, right? Either that unit's name is already used as a key inside the dictionary. So we check this with unit groups that has. So this will return true if the key exists in the dictionary, and will return false if it doesn't. So what we do is we say that if that unit's name is already used as a key inside the dictionary, then we know that the value will be an array. And for an array, we can use the append method to add that unit, right? But if it doesn't exist, it means that this key needs to be added to the dictionary because we find a unit which was not there previously. So we say that the unit group's dictionary's item with the key of the unit's name should be an array with one element, which is that specific unit instance we're currently at. And when we're done with that, we can return that unit group's dictionary because we'll basically have what we set out to do. Let's see the counterpart to this, where we define all the triplets for these groups. So we'll have a get triplets for groups method, and as you can see, it says it returns all the combinations found in the dictionary returned from the previous method. Combinations are stored in an array of arrays, which consists of 3 unit instances. I wanted to specify this because you can have array of arrays where you have a type indicator for the inner array, so that it's not possible to say array unit inside Godot. That's why I decided to type this out as a comment. Right, so our upgrades or triplets array of array is created as the first line of code here, and then we loop through all the groups we have inside the dictionary, right? Each of those will be an array. So for example, if we have 4 Björns and 2 Robins, if we loop through the unit names inside our dictionary, we'll have Björn. And when we reference the dictionary's value for Björn, it will be an array of 4 unit instances. So this is what we store in the current units array. And what we do is a while loop because we can have multiple triplets, right? So it's not guaranteed that we only have 3 units, right? Or multiples of 3. We can have 10 units or 20 or something like that. So what we do is we check if the current units array's size is greater than or equal to 3. And if that's true, we'll create a new array with exactly 3 elements and add it to our array of arrays as an element, right? And when we have that, we can call the array.slice method to remove the first 3 elements from that array. So if we press and hold Control and click on slice, you'll see that it returns a new array containing this array's elements from index begin inclusive to end exclusive, every step elements. So what this means is that if we have an array like this, A, B, C, D, E, F, and we slice for 0 and 2, we'll get the 2 first values. And you might notice that I only used one value here, which will be the beginning index. And if you omit the end index, it will use the biggest index an array can have in Godot. So it makes sure that from index 3, which is the 4th element, we'll grab all the remaining elements inside the array. So in this case, for the letters, slice 3 would result D, E, and F. And that is exactly what we want, because after we grab the combination of the first 3 elements here, we want to have all the remaining ones. And repeat this process until we no longer have a valid triplet. So when this while loop breaks out, we made sure that all the possible combinations inside that array were appended to our upgrades array. Right. And when we're done with this for each of the units or each of the groups, we can return that array of arrays, which will be used, just to make sure you remember, this is stored here, the triplets. And this is what we use to essentially combine the units, right? This array of arrays. So now we did the heavy lifting. The rest is not that complicated, I promise. We only have to implement our two callback methods. So what do we need to do when the buffer timer runs out? Here we have two cases. Either way, we queue a new update. It doesn't really matter what's going on when the timer times out. It means that we have to do an update sooner or later. What might be different is that there might be an animation playing at the moment when the timer times out. So we make sure that we only update the unit combinations for tier 1 when the tween doesn't exist or when it exists but it's not currently running. So when this happens, we don't just add one to the queued updates, but we also do call that update unit combinations method, which is the highest one, right? This one. So we grab the groups, grab the triplets, and do all that stuff. But only if there's no animation currently playing. Otherwise, we just queue an update by adding one to that number. And the final thing we need to do here is to say what happens when units were combined and one instance of update has finished. This can happen for two reasons. If we scroll up, it can happen because we did have something to combine and it has finished playing that animation. Or it can happen because we wanted to update, but there was nothing to update because there were no triplets. And therefore, we did nothing, but we considered this as a completed update as well. So what do we do here? Well, it depends on what tier has finished updating. If it was a tier 1 update that has finished, we have to do a tier 2 update as well, just to make sure that we can chain those combinations together, right? Because if I combine tier 1 units, it might happen now that there are tier 2 units that need to be combined as well. However, if it wasn't tier 1, it means that a tier 2 update has finished. And the tier 2 update is basically the end of the chain because we don't have tier 4. And if that's the case, then we can decrease the number of queued updates by 1. Why? Well, because a queued update means that I should update tier 1, and when tier 1 is finished, I should update tier 2. Because of the chaining, we considered this double update as one piece of update. So when we finish the tier 2 update, we can subtract 1, meaning that one queued update has finished. But we're still not done because we can queue updates, right? This is what we said, that if you buy multiple units in quick succession, this will queue multiple updates one after another. So it can happen that a tier 2 combination is finished, so we subtract 1 from the queued updates, but we might still have queued updates remaining. And if that's the case, we need to start the whole thing again from tier 1. Hopefully that makes sense. If we take a look at this piece of code here, when the buffer times out, we add one to the queued updates, but we only actually start doing the combinations if our tween is not running. So what happens if the animation is still running and the buffer times out again? Then I would have another queued update which is there, but I haven't actually called this method, right? And in this case, I somehow need to resolve that queued update sooner or later. So when a tier 2 update finishes, I subtract 1. And if it's 0, then it means, okay, I'm done with all the updates, we can just chill. But if we still have one or more queued updates in the line, then we need to start the whole thing over again. Hopefully that makes sense. And that's all the code we need. I know it's kind of hard to wrap your head around it. That's why I try to include a lot of visuals and animations to help you understand what's going on here. It's not too long, like 90 lines of code, but can be tricky to think about. So let's save this with Control S. If you understand what's going on here and were able to follow, that's a huge achievement. I think that's one of the most complex pieces of the whole season. So hats off to you. Now let's reap the reward of all this effort, right? Let's test this. Let's see how it looks like. So let's go back to 2D view. And we actually need to add our UnitCombiner to the arena scene. Let's make our file system smaller a bit. Select our arena, our root node, press Ctrl A. And now we know that we can search for UnitCombiner and we can add it directly as a node. Just to stay organized, I'll move it above the UI. And you'll notice that it needs a buffer timer to assign, right? For this to work. So with the UnitCombiner selected, we can press Ctrl A again and search for timer, add a timer node. We can double click on this and rename it to buffer timer. And we need to make sure that it's set to one shot. So what one shot does is, if it's set to true, the timer will stop after reaching the end. Otherwise, the timer would automatically restart. And that's good for something like auto shooting in different intervals in an action game. But for our purpose, we only want the timer to execute once, and we want to restart it by hand, right? That's why we call that start method. So let's tick one shot. And you can use basically any value you want to use as a buffer time. I found that 1 second actually works pretty well. So let's save the scene with Control S. And now let's think about what's the best way to test this. And I think we can use the arena again as a starting point. So let's click on the script icon next to the arena. And we have our unit mover, our unit spawner, cell portal, and shop added. And just to keep things organized, I like to use the same order of these nodes as they have inside the scene tree. So actually, I don't really like the cell portal being under these two. One trick you can do in the GD script editor is if I press and hold Alt and press the up arrow, I can move these lines of code easily. After unit mover and unit spawner, before the shop, we can just drag and drop our UnitCombiner by pressing and holding Control. And now we have access to our UnitCombiner component. And inside our test code for the UI except action pressed, we can delete these 3 lines of code. And instead, we can just say UnitCombiner.queue unit combination update. So for the first iteration, whenever we press enter, we can queue a unit combination update to see how the system works. Let's save this with Control S and run the game with F5. And we do have an error message saying that invalid access to property or key timeout on a base object nil. And it says that inside the unit combiner, the buffer timer is null. Why is that? Well, it's because I forgot to do something as I usually do. Let's go back to 2D view. If I click on the unit combiner, I do have that buffer timer node, but I haven't assigned it as an export variable. So let's click on assign. Double click on buffer timer, and now we should have no error messages. Let's save the whole scene with Control S, press F5 to run the game. Okay, no error messages. This time we can sell the testing units. And if I start buying these units, the robins should combine after 1 second, but they don't. And that's because this is not automatic yet. We do have to press enter, and I haven't pressed it. So if I buy some more units, so let's see how this looks like. If I press enter, wow, something is definitely wrong here, right? Let's run the game again and see what exactly is going on here. Let's buy 4 Björns and press enter. Okay, so we do have the triplet combination, right? But what happened is that tier 1 Björn has become tier 2 as well for whatever reason. Let's see if we can replicate this. So if we buy another Robin and press enter, yeah, it does happen again. Something's definitely wrong here. What if I buy a couple other Björns? Okay, it seems like it's working for whatever reason, right? It seems really strange. The problem again has to do with shared resources. So by default, since we only have 1 resource for each unit, when we change the tier on 1 unit, all the currently used resources will be the same. They will be changed. So if you think about it from this perspective, if I buy 4 robins, what happens is when I combine these 3 into a tier 2 unit, this unit's unit stats resource will be set to tier 2, right? Well, yes, but this unit and all of these essentially share the same resource. So when I change this to tier 2, this will be changed as well. So if I press enter now, you'll see both of those become tier 2 because they share the same resource. So how can we fix this? Well, I think probably the easiest and the cleanest solution is to go to the units script and change the setter function for the unit stats resource. Why? Well, because when we spawn a new unit, we instance the scene and then set the unit stats property based on what these unit cards have assigned to them, right? So at that point, we can say that, okay, assign this Björn stats to the newly spawned unit, but also duplicate it before we do that to make sure that each instance has a unique unit stats resource attached to it. And to do so, let's close the output window for now, go to the script tab, press Ctrl-Alt-O, and search for unit.gd. Inside that script, let's look at the set stats setter function and click on it. And here we can do something like this. We need to make sure that we check for not engine.isEditor hint, because if you remember, this is a tool script, meaning that this code runs in the editor as well, right? So we don't really want to duplicate resources when we are inside the editor, but when we are inside the game and we set to a new unit stats resource, we want to make sure that that value will be duplicated. And that's all we really need to do to solve this problem. So if we save this with Ctrl S, go back to 2D view. So if we run the game now by pressing F5 or clicking on this button, we should no longer have this issue. So if we buy like 10 robins again and press enter, you'll see that the combinations chain together beautifully and that one remaining robin remains tier 1 because it has its own unique resource. If we go to the remote scene tree, we can double check this. If we go to our bench unit grid, we have this one which should be tier 3 and this one which should be tier 1. So if we click on it and click on the stats resource, you'll see that it's tier 3 already. And if we click on the other one, you'll see it's a tier 1. And what's really telling is that it doesn't say robin.tres, it just only displays this unique ID that resource has. So that's it, we fixed the problem. So after fixing this problem, the one final thing we need to do is to actually hook this up inside the game so we don't have to press enter to combine the units, right? And this will be a pretty easy step to do. First of all, we can get rid of all the testing code and the input callback because we no longer need it. And between the shop and the UnitSpawner connected signals, we can add a new one. And what we'll do is when the UnitSpawner spawn unit signal is emitted, we connect it to the UnitCombiner's QUnitCombination update method, which is the same one we used when we pressed enter. And we need to call unbind1. Why? Well, because if we press and hold Control and click on the unit spawn signal, this also passes the unit that was bought as a parameter, right? If you need it for whatever reason. Well, in the case of the UnitCombiner and queuing the unit combination update, we don't actually need that data, because if we press and hold Control and click on this one, it requires no parameters. So now you have a mismatch between the unit spawn signal passing one parameter and the queue unit combination update needing 0. So in this case, it's kind of the opposite of bind. You'll say that, okay, we know that this signal would pass one parameter, but with unbind1, we say that we don't need that one parameter. And with that line of code and deleting the placeholder we had, we should be good to go. So if we press Ctrl S to save this and run the game one more time, now we have the full unit combination logic. So if we start selling units, we can buy multiple ones. You see that there's no immediate update, but if I wait for 1 second, all the animations will be queued. And there's this 1 second delay, and they will be chained together. We can buy more Björns. And everything works as intended. So that's pretty much it for this episode. I hope you found it useful, and I'll see you in the next one. Bye-bye.